Hello all. Welcome to Math for Juniors with me, Miss Marks, and my assistant Snail.
Hi, friends.
You seem a bit low today.
Oh, actually, I want to go on a holiday to Kashmir.
Holiday again? I think you came back from a holiday sometime back only. And why suddenly you want to go to Kashmir?
I want to see snowfall.
Oh, what was that, Snail? Behave yourself.
Oh, I'm just practicing how to throw snowballs in Kashmir.
You throw one more ball at me and I will not give you a holiday for next 1 year.
No, Miss Marks. Please don't do that.
Okay then, behave. Now what are you wondering about?
Why do we have snowfall in Kashmir but not in Delhi or Punjab?
Kashmir is closer to the mountains and is at a higher altitude in comparison to Delhi or Punjab. Hence, the climate there is different. So, altitude is one of the many factors that determine the climate of a place.
Okay, so you mean many factors put together determine the climatic condition of a place. Different factors obviously mean different climate.
Yeah, just like in math.
How?
Like in math, if you multiply x, y and x plus 2 whole y, you get different results. For instance, xy plus 2y is the product in second case.
Oh!
Snail, try to understand. If you are given the product xy plus 2y, you can express it back to its factors y and x plus 2 whole. This process of writing an expression as its products is called factorization.
Oh, but how does one do this factorization? It seems so tough.
Let's go to the virtual world to learn about factorization of algebraic expressions. You have studied algebraic expressions and arithmetic operations on them. Now let's learn one more operation, factorization of algebraic expressions. Now, what is factorization? Well, the process of writing an algebraic expression as product of two or more other algebraic expressions which are called factors of the first algebraic expression is called factorization. In the algebraic expression ax plus ay, a is common to both the terms ax and ay. So, we take out a from both the terms to obtain ax plus ay is equal to a multiplied by x plus y the whole. Here, a and x plus y are called the factors of algebraic expression ax plus ay. So, Snail, how did you find it?
Oh, it was easy.
Really?
And very, very interesting too.
So that means you understood it very well.
Yes, quite well. Very well.
Good. Then let me give you another algebraic expression and you factorize it.
Me?
Yes, you. Since you find it so interesting, huh?
Well, I was thinking, Miss Marks, why don't I see a few more examples and then solve your question?
All right. Let's see some more examples on factorization of algebraic expressions. But this time, you better pay attention, Snail, or...
Sure, I will.
Good. Off to virtual world. Let's factorize the expression x plus 6xy minus 9xz. Let's check out for the common factors. Here, the common factor to the three terms x, 6xy and 9xz is x. Therefore, the expression can be factorized by taking out x common. So, x plus 6xy minus 9xz is equal to x multiplied by 1 plus 6y minus 9z the whole. Now, let's look at another example. Factorize the expression 6x raised to power 4 into y raised to the power 3 minus 12x cube y minus xy. The common factor in this case is x times y. Taking out xy, we get xy multiplied by 6x cube y square minus 12x square minus 1 the whole. Notice that by multiplying the common term to each of term inside the bracket, we obtain the original expression back. This way, we can verify if the factorization done is correct or not. Here, the factorization is the reverse of expanding brackets. Back to the real world. So, Snail, I hope this time you understood it very well.
Oh yes, I did it and it was actually interesting.
Math always is interesting, but you need to pay attention. Like you pay attention to movies or to food?
How does she know that I was thinking about a movie? Oh my god, what if she marks me absent? Yes, I will, Miss Marks. What is that toy on this table? Can I play with it?
You can if you find the factors of that toy.
But how can I find factors of the toy? Isn't factorization restricted to numbers and algebraic expressions?
It is, but it has a broader meaning as well, which is not just restricted to algebra.
Oh, then why don't you tell me about it?
I will, but before that, we need to see another method of factorization of algebraic expressions, which is by grouping the terms. So, let's go to the virtual world. Factorize a cube plus a square plus a plus 1. In the given expression, we do not have anything common to all the terms. So, we shall use another method to factorize the expression, that is, by grouping the terms. First, divide the terms of the given expression into groups in order to find the common factor from each group. Grouping the terms as a cube plus a square and a plus 1, we get a square as a common factor from the first group and 1 from the second group. Now, both groups have common factor a plus 1. On taking a plus 1 as common factor from both the groups, the given expression reduces to a plus 1 into a square plus 1. Thus, a cube plus a square plus a plus 1 is equal to a plus 1 into a square plus 1. Still wondering about the car?
Yes. You broke the car.
No, I just factorized it or reduced it to its basic building blocks.
Oh, I didn't get that.
Factorization in mathematics means the same as in English language. That is, it is reducing or splitting an object into its constituent products or factors. The aim of factoring is usually to reduce something to its basic building blocks.
Oh, that's why the car blocks. Now I got it.
Snail, I have another very interesting phenomenon to tell you wherein the factorization takes place. Let's check that out in the Do You Know section. Do you know that the sunlight, also called as white light, can be split into its constituent colors? Red, orange, yellow, green, blue, indigo, and violet.
But how can you split the sunlight?
There are two ways to split the sunlight. First, we can do it with the help of this prism. Look at this closely, friends. When the sunlight passes through prism, it splits into its constituent colors. See?
Wow, I can see. So that is how we factorize the sunlight through a prism.
Yes, and there is another way as well.
What is that?
I'm sure you all must have seen a rainbow before, and that's an example of splitting of white sunlight. On a rainy day, if you stand with your back to the sun as you look into falling rain or a mist of droplets, you will notice the rainbow made up of 7 colors: red, orange, yellow, green, blue, indigo and violet. This range of sunlight colors, when combined, looks white to the eye. This property of sunlight was first demonstrated by famous mathematician and physicist Sir Isaac Newton in the year 1666.
Wow! We just factorized the sunlight first by prism and then by a water droplet.
Now it's time that I press the action replay button so that you all can quickly revise all that we have learned today about factorization. So friends, sit tight and pay attention. Factorization is the process of writing an algebraic expressions as product of 2 or more other algebraic expressions, which are called factors of the first algebraic expression. An algebraic expression can be factorized by taking out the common term, grouping the terms. What are you doing with those blocks?
Actually, I broke the car. Was trying to create the car model back with these blocks. Can you help me?
In the process of reversing the factorization.
Of course!
Anyways, time for me to say goodbye to my dear friends. But you continue your fun with algebraic expressions. Till next time, goodbye.
Bye! See you in the next episode!